Okay, chapter 6 begins today, and we're going to be doing trigonometric identities for the first few sections of this. Solving trigonometric equations is the back section of it. Determine if sine of x plus pi over 6 equals sine of x plus sine of pi over 6 is an identity. So an identity means that regardless of the value of x, I've got a left side of my equation, I've got a right side of my equation, regardless of the value of x, that the left-hand side and the right-hand side are exactly the same. That's what an identity is. It's really easy to check to see if something is an identity or not. You go to your calculator, and you enter the two functions, left side and right side, in your calculators, y1 and y2. And I want to go, before I type this in, I'm going to go over here to the left and get this line highlighted over here, hit enter, and I want to change the line style. Just click down and click over like this. If you have the T83 plus, it's just, I think if you just keep hitting enter on that, it just goes through those things. But I want to do a dotted line for the first one. And I'm going to do a solid line for the second one. Alright, so y1 is going to be the left-hand side, y2 is going to be the right-hand side. If you see radians like that, it's going to be, typically graphing trig functions, it's going to be in radians. Alright, so sine of x plus pi over 6 in parentheses. And the right-hand side says sine of x in parentheses plus sine of pi over 6 in parentheses. All right, those are the two things we're supposed to graph. As far as windows are concerned, maybe negative 10 to 10 on the x-axis. As far as the y-axis is concerned, sine we know goes up and down 1, right? Maybe up and down 2 just to really get a good look at it. Oops. Negative 2 to 2. Hit graph. Now, the dotted line goes first, and I'm in degrees. So obviously it's an identity because they're exactly the same. Yeah, right? Hold on, let me get it into radians so we can hopefully see the real truth, if that happens to be that it's an identity. All right. So now hit graph again. So here's the first one, the blue graph, and there's the red graph, and you can see that they are not the same. Okay, if the red graph went directly on top of the blue graph, then it would be the same. There would be an identity. That means all the values of x on one are all the values of x on the other. And then we'd have to go ahead and verify that. All right? For a non-identity, all you have to do is show me a counterexample. Find me a value of x where they aren't equal to each other. There are billions of answers here. I don't care which one you pick. I can see where, for example, I did x at a scale of 1, I believe, right? Yeah, x at a scale of 1. So obviously 1, they're not the same. 2, they're not the same. I'm going to pick 2. They're way off on 2, right? So if I just pick x equals 2. All right. So what I'm going to do as far as showing work on this is concerned, I'm going to write y1 equals sine of x plus pi over 6. And y2 is equal to sine of x plus sine of pi over 6. I want you to write on your paper what you're entering in your calculators as the functions. I want you, if it is not an identity, to identify a value of x for where they're not equal. And you can say at x equals 2, y1 equals, and y2 equals. Those should be different numbers. And the way we determine the values of y1 and y2 is we simply go to our table and type in the number 2. And you can see very clearly y1 and y2 listed there. They aren't the same number. I mean, a couple decimal places is sufficient to demonstrate that. So 0.58 and 1.41. So that's the extent of that problem. So not an identity, give me a counterexample. Because again, if it's an identity, for every value of x, they're equal. So if you can show me even one value of x where they aren't equal, you're proving it's not an identity. And that's the extent of the problem. The first 10 problems in the homework section, I don't know if they're the first 10 problems you have to do, but the first 10 problems in the section, if I remember right, are not identities. You just have to give me a counterexample. The remaining problems are all identities. You'll have to prove them. So and the directions for the first 10 are this. the directions for the rest of them are verify the identity. They're going to specify they are, but I don't think any of the first 10 are. So just keep that in mind.